In today's video, I'm gonna be building one of the most popular AI robots on this planet, and that is the AI controlled robot Doc. So you're asking yourself right now, how do you want to build that robot, bro? So in the first part of this project, I'm gonna be building it as a controller controlled bot, so I can control it by myself. I'm gonna be doing that so I can understand the movement and other stuff for later when I'm gonna be building the robot as a self-controlled AI robot. So let's gonna talk about my plan, how I want to build the robot. So firstly, the robot consists of two parts, the robot itself and the controller. Both of them are going to be controlled by ESP32s, so these are going to communicate on ESP now. That should allow them to communicate behind walls and stuff, and the rest would just be a few servos and cardboard because I don't have a 3D printer. So let's get started. So I just found these little ice cream sticks in my house, so I think they're kind of good for the legs. So I think I'm gonna use them. So firstly, let's understand how our robot needs to move and how the legs are going to be builded. So for our movement of the robot forward and backward, we're gonna use the walk, hold, trot. That means we're diagonally two legs are moving at the same time. So that means front left and back right and back left and front right. That is the fastest movement we can get out of our robot. Good. Now I have glued all the legs to the plate and this is how it looks like now. And it looks perfect. I don't know, it's fire, dude. Okay, now let's go talk about the controller. I forgot to record while building the controller, so here is how it looks like. So it's a pretty simple design. So here's a little explanation. First things first, this is the joystick which controls where the robot should walk. So second, these buttons are just like some fun buttons. They just say the robot just should jump or stuff like this. Third, these LEDs right here showing the current state of the connection to this controller from the robot. So basically if it's disconnecting or like some little issues with the connection. Oh yeah, and by the way, this is how it looks like on the back of the controller. Not pretty tidy, not gonna lie. Now let's have a look at the robot itself, how the electronics look like. So this is the overview of the bot electronics itself. So first things first, these are the battery packs that are powering the PCA. PCA is just a regular servo motor controller that can control 16 servo motors, but we only need 8. Secondly, this is the ESP that runs a code and is receiving the signal of the controller, so it knows what to say to the PCA, to the servo motors and stuff like this. Okay, so now I built the exact same structure that I just have shown to you, so this is how the bot looks like now. Okay, it's finally time to make our first running test of the robot without the controller at first. So just to look how it walks. Oh. But like, yeah, the issue is that the legs are not perfectly straight. Okay, as you have seen, the robot is walking perfectly, but there is a little issue. The legs are not that stable enough, so they're like a bit crooked, so that's why the robot isn't walking that straight. So I need to find a way to fix that problem. But besides this, the robot is walking perfectly. Nice. Now I just need to connect the controller and run the code, and let's see what happens. It's disconnecting. See? I don't even control it. I'll research for causes why it's disconnecting, because I cannot explain myself why it's disconnecting every time I'm steering the auto ESP. So as you just have seen right now, the robot has a little issue, and that issue is that the robot disconnects to the controller. So that means every time I'm steering it, when it's walking forward, backward, etc., it's disconnecting every time. So I need to fix that problem. So I actually found the problem, and basically it was only a little bug in my code. Now it's working and I'm so happy to see that. Yeah, it's now not even disconnecting, not even a bit. Okay, now let's analyze the problem. See, the ESPs are communicating on ESP now. ESP now is just basically receiving information from one ESP to the other one under 100 milliseconds. That means if a received information comes over 100 milliseconds, the ESP is automatically disconnecting. And in my code, I defined the movement of the robot in the loop where the ESPs are communicating with each other. So that means every time I added delay was going over 100 milliseconds of delay, so that means the ESP was just disconnecting, and that's the issue. Now, after I fix that problem, let's add some safety on our robot. Okay, so now I just added a little corpus for the electronics, so it's a bit more safe of crashes, so that the electronics don't break.
The batteries, everything fits here. I glued it here with some hot glue stick. Everything perfect.
Now, let's fix the other problem with the unstabilization with the legs.
Left side, the other one, the right side. There's a little instability out here. For example, this. And that makes many problems if we want to turn around the robot or like make it jump.
So basically, as you have seen, the legs are a bit shaky up here. So basically, I think we need to add something like this leg supports. So let's get started with adding the leg supports to the legs.
So we have finished the upper support legs. I hope there is not much friction, so it doesn't rub that much for the servos. Hopefully there is not much friction.
Okay, let's actually try it without the under leg supports and see what happens.
Okay, so hopefully it works great. Let's try it out. Oh my god.
Okay, so the upper leg supports are actually looking good while walking, but besides the glue stick that isn't that strong to hold this leg support, so I need to find a better glue stick. But anyways, let's hop on to the second layer on the under leg supports.
So now the robot looks like this. But first things first. It looks so good. Okay. Bro, why is it disconnecting? But now it's like the motors aren't working at all because it's saying stay connected. Well, the motors aren't working. I'm like pushing it up and nothing works. And the batteries are plugged in. These are the batteries for the PCA. Bro, I need to fix that.
Okay, so as you have seen, that was a complete fail because the PCA broke. Here's how I'm gonna explain it. The PCA broke because there was too much friction on the servos, so PCA couldn't handle that. So now I need to buy a new PCA, check the servos and stuff. So subscribe for part 2. But for now, thank you guys for watching, and I'll see you in part 2 of this project.